Okay, welcome. Today I'm going to show you how you can prove that the system of equations method is viable. And the way we're going to do this is we're going to actually solve a system of equations both with elimination and with substitution. And we're going to show that you actually get the same answer no matter which method you do it. In order to make it a proof though, we can't use actual numbers, so we're going to use everything with letters. So the first equation I'm going to use is ax plus by is equal to c. X and y would be your normal variables, and we're going to just replace a, b, and c, which would normally be numbers, with just other letters. And I need to do it the second time as well. So again, we're going to use x and y as our variables, but I need to have coefficients here and a constant. So instead of a, b, and c, I'm going to use h, g, and we'll use f. Okay? So we need to first use the elimination method to solve it. Now I would like to have these two, when I add up, end up equaling 0, because that's how elimination works. And I need to change this bottom equation so that that happens. Now you know from elimination that you're allowed to multiply this equation by some number in order to make that happen. And the number I'm going to choose actually is negative a over h. And it's really important that you look at why this works. If I multiply h times negative a over h, you have an h on the top and the bottom, and these two are going to cancel, which leaves negative a. And if I have negative ax and I add ax to it, anything plus its opposite, say like I have 2 plus negative 2, this equals 0. So when I add these up, this is going to cancel. I'm just going to be left with the y. So I'm going to do that. Now there's an unfortunate consequence that these are going to get messy, but we can't avoid those. So we're going to multiply everything, both sides, by negative a over h. So let's go ahead and do that. Negative a times ah is going to be negative ah, excuse me, the h is gone, negative ax, because the h's cancel. For this one, using the distributive property, I got negative a times g. So we're going to write minus ag. And we're still going to have the divide by h. And I'm going to put the y outside. And this is allowed because y divided by 1 multiplied by this is going to be the same thing, and it will help us later. So I'm going to put the y outside. So we get negative ag over h times y. And on this side, we're going to just multiply it out. So we get negative af over h. Now, our goal is to get these canceled, so we're going to actually get rid of this middle equation right here. Before I do it, I want to rewrite these on the next one so we can do them again. So our equations were ax plus by is equal to c. And we had hx plus gy is equal to f. Correct? Correct. Okay, so when we get to substitution, we're going to use the same equation. So I'm going to get rid of this one just so that you can see it. Now on your page you don't have to erase it, but I want you to see that we're going to add these two up. So when we add this up, you get ax plus a negative ax is 0, so those cancel. So these are gone. We're going to add these up, so we get by plus a negative ag over hy. And outside we're going to have c plus a negative af over h. Now, I didn't write the plus and negative, but remember, plus and negative means minus in math. So this is plus and negative, this is plus and negative. I'm just saving a little time and writing them as minuses. So the goal here is to get y by itself, so I need to combine these. Now, normally if I had something like 2y minus 10y, we would do 2 minus 10 first, get an answer, and then we put the y outside, and you would tell me this is negative 8y. I can't actually do this last step because I don't know these numbers, but I can write it like this, and that's what we're going to do. So I know the y is going to be outside, and what would I have to subtract is this b, just like this 2 was, and this ag over h, and that's some number. I have no idea what it is, but it's definitely a number, because if I multiply two numbers and I divide by a number, I'm going to get a third number. So this is some number, and when I subtract this number minus whatever this number happens to be, I'll get yet another number. So this method still holds. And then on this side, we're just going to rewrite it, c minus af over h. Now lastly, whatever this coefficient is, you're going to divide by it. So we're going to divide both sides by b minus ag over h. And I'm going to do it over here too, b minus ag over h. And I'll write the answer up here. So we get y is equal to, now if I take some number and I divide it by itself, say you got 10 divided by 10, this always equals 1, provided that these aren't zeros. And so these are not zeros, so when we divide these we get 1. Over here we're just going to rewrite it. So I got c minus af over h divided by b minus ag over h. Now we're going to leave it like that for now, but we may have to change it later when we look at how we solve it, because both kinds I need y equal the same equation. So we got c minus af over h, and on the bottom we had b minus ag over h. So we're going to take this aside, and now we're going to do the same thing this time with substitution and solve it for y. So for substitution to solve for y, I need to get this solved for x, so I can plug it in up here. So we're going to take this and we're going to solve it for x. So this is a two-step equation. First thing I need to get x by itself is I have to move this thing. So we're going to just subtract gy from both sides. And this gives me hx is equal to f minus gy. Next thing I'd have to do is divide by whatever this coefficient is. So we're going to just go ahead and do it. We're going to divide both sides by h. And so now I say x is equal to f minus gy over h. This is where the substitution comes in. So I'm going to take this and I'm going to plug it into the other equation in place of x. So I got a times, now instead of x I'm going to write all of this. So I got f minus gy over h. And I still got plus y. And we still have equal to c. Now we have to get rid of these parentheses, so we're going to distribute. So I got a times f is af. I'm also going to separate this fraction out. So this you might not have seen before. But if I have a fraction, say like 1 plus 3 divided by 2, this is the same as 4 over 2. But I could separate it out and make this 1/2 plus 3/2 is also equal to 4 over 2. So we're going to take this out and we're just going to go straight to this. So I'm going to, the denominator has to go to both parts of the numerator. And I'm going to do that as well. So we got a times f over h minus gy over h plus by is equal to c. And now I'm going to use the distributive property. So we're going to distribute this a to everything in the parentheses. So I got af over h minus ag over h times y. Now this might look a little weird, but you are allowed to do this. Because if I multiplied this out, I'd have ag over h times y over 1. And when you multiply that out, you get ag y over h, which is what you were probably going to tell me this is supposed to be. So these are actually the same. But it'll be helpful in a minute to have it just as y. So I'm going to leave it like that. And then I still got this plus by and equal to c. Now the reason I did that is we need to do two things. One, I need to move our constant to the other side, so it needs to be over here. The other thing is I need to get these y's together so I can distribute. So I'm going to do both of those things. So the first thing is we're going to just subtract this constant. It happens to be af over h, and whatever it is, we're going to subtract it from both sides. So any number subtracted by itself happens to be 0, so I'm left with ag over h times y plus by is equal to, and then subtracting this we get c is minus af over h. Now, just like we did on the other screen when we were back here, we had a little trick where we could take the y out and we put this together. We're going to do the same trick over here. So I know that it's going to be y, and everything I see before it, we're going to just put. Now I'm going to switch the order. I'm going to put this b first, because by switching the order and putting the by over here, it's going to look like the other one. And you know you can do that because 2 plus 3 is equal to 3 plus 2. In this case, we're going to have something more like negative 2 plus 3 is equal to 3 plus a negative 2, which happens to be 3 minus 2. So we're allowed to switch the order as long as the signs stay with the number. So that's what I'm going to do. And then I'm going to separate it out. So we got b minus ag over h. B minus ag over h, and then the y's are right here. And over here we still have c minus af over h. Now the last step is we got to divide both sides by this 1. And you're going to end up with, when you're done dividing, the numerator will be c minus af over h. And the denominator is going to be b minus ag over h. Now if we go back and look at what we had y equal to before, we had c minus af over h, c minus af over h. And the denominator was b minus ag over h, and look what we have, b minus ag over h. So I still don't know what these numbers are, but whatever this number right here is, that I'm going to circle in red, whatever this number is, and whatever this number is, it's the same number. So effectively what we said is that y is equal to 5 here. I don't know if it's really 5, but it's equal to some number. And here, it's equal to whatever this number is, happens to be the same number. So I don't really know if it's 5, but that doesn't matter. What matters is that this number is exactly the same number over here. So because they're equal to the same number, we've just shown that these two methods give you the same answer, and we call this a proof. So you would finish up a proof by saying a line that says, since both methods show that y is equal to, and then you have to say what y is equal to, c minus af over h divided by b minus ag over h, then the solution method is viable. And that's how you finish off a formal proof. So if you have questions, I know this is a difficult topic. This is actually a level 4. Make sure you ask for help, but this is what you would have to show me if you'd like to be a 4. If you have questions, come and see me in class.